Hey everyone, in this video we are going to talk about graphing linear functions. This should be a review for you from Math 1 and even in 8th grade math, but it's important that we talk about it to prepare us for the lessons that we're going to be talking about in the future. So our objective today is to be able to graph a line from any form, basically. Now there's two main forms that we're going to focus on. Notice I've got my notebook already set up. I've got my title, I've got my essential question, and I'm ready to go. Remember, your notes go on your right-hand side, and your essential question is written from the objective that I give you. Now, my essential question looks a little bit differently because you can pull any question you want out of the objective that you think is beneficial. And in fact, if you find it easier to write your essential question after you take the notes, that way you know what the notes are about, and then it might just be easier to write a question off of that. Go ahead. Remember, your summary has to answer the essential question. But with that said, let's go ahead and get started with this lesson. Remember, I said there are two forms of a line. The first form is slope-intercept form, and that's the one you're probably more familiar with than anything else, and that is y equals mx plus b. We know that the b is the y-intercept and that the m is the slope, okay? So if I give you an example of this, y equals negative 2/3 x plus 1, we would want to identify all the two key features here, okay? So let's see, two forms. And I'm not going to always take notes with you guys. I'm just trying to help you understand how I expect it to be done. Slope-intercept form is y equals mx plus b, and we know that the b is the y-intercept, and that the m is the slope, okay? So our example of this, our example says y equals negative 2/3 x plus 1. All right, so this is where graph paper is essential. Now notice I'm using a graph paper notebook now. You don't have to, but when you're drawing a graph, what I'd like you to do is draw the graph on a piece of graph paper. Remember, that was one of the requirements for the class. And then you would cut the graph out and paste it into your notes, okay? So with that said, we have our example. Our example says negative 2/3 x plus 1. So we're going to identify two things. The y-intercept. The y-intercept is a coordinate. It's 0, 1. And you'll see why in just a second as we graph it. And then the slope is negative 2/3. Okay? So when we go to graph this, our y-intercept, most students and a lot of teachers would just say, oh, it's 1. Technically, it's 0, 1. Why is that? Because I'm starting up 1. I always start up or down when I'm in slope-intercept form. Well, what is this coordinate? This coordinate is 0, 1. We didn't go side to side. We only went up 1. So the y-intercept is 0, 1. Now, the slope says negative 2/3. Well, that negative means that the line is going downhill from left to right. You can be at the top of a mountain, and you could go down that mountain in any direction. But in math, we have some rules. And one rule is that we always read left to right. We read a graph from left to right. So as I move from left to right, we should see this line going downwards, okay? If we see it going upwards, then the slope would have to be positive, okay? Now, remember, a negative, I'm going to put this off to the side, a negative 2/3 can be rewritten as negative 2/3, but it also can be rewritten as 2/-3. All three of these are equivalent. So that means when you go to plot your next point, you can go in either direction. Remember, slope is the rise over the run. So here, I'm going to go down, well, in this case, I'm going to go down 2 and to the right 3. So I'm going to go down 2 and to the right 3. You can see that, down 2, right 3. But in this case here, I could go up 2, but I'd have to go back 3 because that's a negative 3. So if I go up 2 and back 3, that puts me up 2, back 3. You can see that all three of those points are in a line, and so we know we did it right. We can also see that this line goes downwards as we move from left to right. So that's my example of how to graph a line using slope-intercept form. With that said, let's go ahead and look at the other form, which is point-slope form. Point-slope form. Okay. Now, you've probably seen it as y minus y1 equals m times x minus x1. I'm going to use different variables for you because that will help us in this year's math when we talk about parabolas and quadratics. I'm going to use y minus k equals m times x minus h. Well, what do these letters mean? Remember, the y and the x are the variables in a sense. This is the independent variable and this is the dependent variable. The m, of course, is going to be the same thing as it was in the slope-intercept form. M is slope. So I'm going to write this down. Y minus k equals m times x minus h. And then we know that the slope is still m. Well, what is the k and the h? The k and the h are actually a point on the graph. So I'm going to write that down. H comma k is a point. Okay. Now it's really easy to identify the point. Watch this. Here's an example. So m is a slope. Here's an example of this. Y minus 1 equals 2 times x minus 3. So you can see on my notes, I didn't really leave room for my graph. I'll probably graph it and then glue it right here over this little notation here. But you should probably leave some space so you have room to graph. But here we have y minus 1 equals 2 times x minus 3. Well, we know that the slope is 2, okay? We know that the slope is 2 because that's my m value. What is the point? What does the h and the k mean? Well, the point, remember, is written as a coordinate. And just like in slope-intercept form, you had a point. You had the y-intercept. Let me go back to that for a second. You had the y-intercept. It was given in the equation. It was 1, but we wrote it as 0, 1. Well, when we're graphing off of point-slope form, we still need a point and we still need a slope. So we know the slope is 2. The point is given here. It's the 1 and the 3, or the -1 and the -3, okay? Now notice this. It says that h is the x value, and that makes sense because it's right next to the x. And the k is the y value, because it's x comma y, because it's right next to the y. Notice these minus signs here. This says h, this says negative h. This says k, this says negative k. So whatever you see here for, you see a -3, that means h is +3. It's the opposite. So we would say that the point is 3. And then because this says -1, it would do the k value is the opposite of that. So it would be +1. So that right there shows that we have all the information we need to graph this line. We know a point to start at, and we know the slope that we need to follow. Before we go any further, remember 2 can be rewritten as a fraction, so we can see it as a slope as 2/1. Okay? So let's go ahead and graph this. We know the point is 3, 1. So we're going to plot that point. That means you're going to go to the right 3, and you're going to go up 1. And then from there, we're going to follow the slope. And I'm going to emphasize this. From there, from that point, not from the y-intercept, not from anywhere on the graph. We're going to start at this point that was identified, and we're going to follow the slope. Because the slope is 2/1, this is a positive slope, so we should see it go uphill. We're going to go up 2 and right 1 and put a point there. Now, just like I did over here off to the side, I'm going to do the same thing here. Since the slope is 2/1, those are both positive. So that means our overall slope is positive. What's another way of getting a positive number? When we have a fraction, when we divide, another way is to say -2 over -1. Don't you agree? Negative divided by negative is a positive? That means instead of going up and to the right, I could also go down and to the left. So I'm going to go down 2 and back 1. And notice I plotted every point that I possibly could on the graph. Let me go back here. So I started at 3, 1, I went up 2, right 1, and then I went up 2, right 1 again, just because I had room on my graph. And here I went down 2, back 1, down 2, back 1, because I had room on my graph. I even did it one more, down 2, back 1. And so now we can see the graph of that line. And again, you should be putting that in your notebook on graph paper, cut it out and paste it. Okay, so that's my example for point slope form. Now, here's another example. I'm going to go ahead and minimize this so we can see it a little bit better. Let's look at this example. It says y plus 2 equals negative 1/2 times x minus 4. The reason I have this example here is so that you can see, so you have another view of the point, because the point can be a little odd to look at. First, we know the slope. What is the slope? The slope is negative 1/2. And now we need the points. Well, the points, I'm going to write it as a coordinate here. The point is something comma something. Well, what is the x value? The x value is whatever is in the parentheses here. We just change the sign. So since that says negative 4, we're going to change that to a positive 4. Okay. And the y value, the k, since that says positive 2, we're going to change that to a negative 2. So that is our point. And then from there, we'll plot that point and the slope. So here's my graph. I'm going to start at this point. So I'm going to go to the right 4 and up, or sorry, down 2, right 4 and down 2. Oh, can't see it because there we go. And then from there, I'm going to follow my slope. Now you'll notice when I go to follow my slope, since the slope is negative 1/2, I need to go down 1 and right 2, but I run out of room on my graph. So instead of going negative 1/2 for my slope, what's another way of saying that? I could go down 1 and right 2, but I could also go up 1 and back 2. So that's exactly what I'm going to do here. I'm going to go up 1 and back 2, up 1 and back 2, up 1 and back 2. And I'm going to keep that pattern going all the way on. I'm going to check my work, connect the dots, check my work. Because the slope was a negative slope, I should see the line going downward from left to right. And that's exactly what I see. So those are my examples of slope-intercept form and point slope form. Here are your practice problems. Remember, practicing goes on the left-hand side of your notebook. So I'm going to go ahead and flip my notebook over, and I'm going to do these problems on my graph paper here. So for practice problem number 1, we've got y equals 4/3 x minus 5. You should probably pause the video and do it yourself to see if you know how to do it, and then come back and watch the video to make sure you're good. Okay. All right. So hopefully you paused the video and you have done it yourself. So there's my graph. Well, what do I know? I know that my y-intercept is 0, negative 5. 0, negative 5. Notice this is a little bit different than the point slope form. Whatever that sign is there, you're going to hold it there for slope intercept. And then we know that the slope is 4/3. So I'm going to kind of go a little fast through this. I'm going to go down 5. Oops, I went a little off the page here for my graph. I'm going to go down 5. And then from there, this is a positive 4/3. So I'm going to go up 1, 2, 3, 4, over 1, 2, 3, put a point. And then if I can keep going on the graph that I drew, I would, but I'm just going to go ahead and connect those dots, and there is my line. Okay. For number 2, again, you should have already done this. We got y minus 6 equals negative 1/4 times x plus 2. I'm going to identify my points first. My point is the opposite of these. So it's negative 2, comma, positive 6, x, comma, y. And then, of course, the slope is negative 1/4. So go ahead and graph that. What do I got? I got negative 2, 6. So I'm going to do a little bit of a different, I don't have it centered necessarily, because I know I need to start at negative 2 and then up 6. So that's negative 2, 6. And I'm not labeling these. I mean, you should probably label them as 1, 2, and so on, but I'm not doing that right now. The slope is negative 1/4, so I'm going to go down 1 and over 4. And I'll do it again, down 1 and over 4. And you can see the dots. If you connect them, you get your line. And so there is my answer for number 2. For number 3, We've got y equals negative 3x plus 5. We know, I'm going to just kind of skip over writing things down. Hopefully you've identified the y-intercept and the slope. But the y-intercept here is 0, 5, so I'm going to go up 5, and then I'm going to follow the slope. Well, oops, can't see that on the camera here. Okay, so the slope is, maybe I should write it down, negative 3, but remember we write it as negative 3 over 1, which means we're going to go down 3 and right 1. Down 3 and right 1 until we run out of room. Or we could go up 3 and back 1, but that's off my graph, so I'm not going to do that. And then connect the dots, and you have your line. Okay. Number 4, last one for graphing here, we got y equals, y plus 7 equals 1 times x plus 6. Well, our points, remember, change the signs, negative 6 comma negative 7. And our slope is 1. What does that mean? That means 1 over 1, right? 1 over 1. So we'll go ahead and graph this. Negative 6, negative 7. Now, my graph is going to look a little different here because I got to go back 6 and back 7, so I want to leave some room over here. Back 6, 2, 4, 6, and down 7, 2, 4, 6, 7. So I'll put my point there. And then from there, I'm going to follow my slope of 1 over 1. Up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, and so on, and so on, and so on, and so on, and so on. I'm going to hit every point that I can on my graph. Okay? This one, you can get a lot of points, so get a lot of good ideas for what this looks like. I was off a little bit on that point there. But anyways, that's the 4 graphs that you had. Hopefully you did those all correct. Let's go ahead and look at the next thing here. We're going to go back to our notes. And I'm not going to write this down for you, but it should be in your notes down below. Converting from point slope to slope intercept. So here you know how to graph a line using slope intercept. You know how to graph a line using point slope. But they should represent the same thing essentially, and we'll talk about that. So here's an example of point slope. Y minus 8 equals negative 3 over 2 times x plus 6. We're going to go ahead and convert this to slope-intercept form. Well, what's slope-intercept form? Remember, it was y equals mx plus b. There were no parentheses, and the y is by itself. So the first thing I want to do, just like solving equations, the first thing I want to do is get rid of parentheses. I'm going to distribute. Well, I guess let me take a step back. I'm going to graph this first. So what's the point? The point is negative 6 comma positive 8. Remember, we changed the signs there. So back 6 and up 8. And then we're going to follow the slope of negative 3 over 2. So down 3, right 2. Down 3, right 2, and so on and so forth. So we can see that line. Now, we can write an equation straight off of this in slope-intercept form because we see the y-intercept. What's the y-intercept? It's negative 1. And we already know the slope. So we should be able to say, and I'm just going to write this down, we should say that the equation is, remember, y equals mx plus b. We know that the y-intercept is negative 1, so we're going to say minus 1. And then the slope is the same, so negative 3 over 2. So that's our equation. Now that's not the proper way of converting. We're looking at a graph to see this. Sometimes the graphs are more difficult to see, so we're going to do what's called analytical, okay? So we're going to take the y minus 8 equals negative 3 over 2 times x plus 6 and convert it. We're going to distribute first, okay? So when I distribute the negative 3 over 2 to the x, I just get negative 3 over 2x. What do I get when I distribute the negative 3 over 2 to the 6? Well, I'll write this down just as a side note for work. Negative 3 over 2 times 6. Remember, we're multiplying fractions here, so that's going to be over 1. And then when we multiply straight across, so that would be negative 18 over 2. And then the negative 18 over 2 simplifies to negative 9. So negative 3 over 2 times 6 is negative 9. And I wrote it down there. Now we need to get the y by itself. So how do I get y by itself? Well, I add 8 to both sides. So I get y equals negative 3 over 2x minus 1. And look at that. That's exactly what we came up with from the graph. If we were to graph this, we would start at negative 1. And we'd follow the slope of negative 3 over 2. I'd end up in the same exact points. So you can see that this equation and this equation are actually the same thing. They graph the same line. They just look different. This one starts at a different point than this one does. But notice there's a lot of points on a line, so you can almost start at any point you want and be okay as long as you know what point that is. All right, with that said, I'm going to have you guys turn it over to the practice side, left side, and convert all of these for me. Okay, now I'm out of room on my left side, so I'm going to go ahead and turn my page over, and I'm going to do some more practice on the back side here. Go ahead and pause the video and do these, and then come back and see how you did. All right, for the first one, we got y plus 1 equals negative 4 times x plus 5. Well, we need to, first step, we need to distribute that negative 4. So we're going to end up with y plus 1 equals negative 4x minus 20. And then we're going to subtract 1 from both sides. And we end up with y equals negative 4x minus 21. And that is our final answer for number 5. For number 6, we got y minus 7 equals 5 over 4 times x plus 8. We're going to distribute that. Here we got a fraction. So we've got y minus 7 equals 5 over 4x. And then when we distribute this guy, I'm going to do that work off to the side. I'm going to write down 5 over 4 times 8 over 1. And then 5 times 8 is 40. And 4 times 1 is 4. And that simplifies to 10. 40 over 4 is 10. And so we end up with plus 10 here. Then we will add 7 to both sides to get rid of that negative 7. And we end up with y equals 5 over 4 times x plus 17. And that is our final answer there. So hopefully you got both of those right. Let's go ahead and go on to our last slide, talking about slope and more of the analytical approach to slope. Remember, the slope is the steepness of a line. So this should be on your right-hand side of your notes. Okay, it's the steepness of a line. We have another way to look at it is the change in the y's compared to the change in the x's. So if I go back to one of my graphs here, what is my slope for this problem? It's negative 1/4. My slope for this problem is negative 1/4. So it's the change in the y value. This is the change in the y value, and this is the change in the x value. Okay, that's what slope is. Now remember, there's a slope formula. The slope formula is y2 minus y1 over x2 minus x1. Okay, the slope formula is y2 minus y1 over x2 minus x1. So I'm going to go ahead and write this example down, or at least do the work on the paper just to make sure we're good with this. We've got 2 points, 5 comma negative 4 and 8 comma 4. And our job is to figure out the slope between those 2 points. Well, let's identify our y values. Our y values are negative 4 and 4, because remember, coordinate is always x and y. Our x values are 5 and 8. So all we have to do is plug that into the formula. y2 minus y1 over x2 minus x1. Now I like calling this 0.1 and this 0.2. You can label another way if you want, but that helps me plug in correctly. So what is my y2? Well, this is my 0.2, and that's the y value. So it's 4, and I'm going to put that in parentheses, minus, what's my y1? That's 0.1, and that's the y value for it, minus negative 4. You can see the importance of putting parentheses here because I have a minus and negative. If you don't put the parentheses, you might forget a negative sign somewhere. Over, what's my x2? My x2 is 8, minus my x1 is 5. And then we'll simplify that. 4 minus negative 4 is actually 4 plus 4, which is 8. And then 8 minus 5 is 3. So my slope is 8/3. Okay. Now, for your practice, go ahead and do this on the left-hand side. Find the slope between these 2 points. Negative 3/7 and 2 negative 8s. All right, hopefully you have done that before you watch this. Let's go ahead and do this practice problem. We've got negative 3/7 and 2 negative 8. Well, let's see here. We've got, we're going to call this 0.1 and 0.2. Okay. And remember, it's y2. So we're going to say negative 8 minus y1, which is 7, over x2, which is 2, minus x1, which is negative 3. And then that simplifies. Negative 8 minus 7 is negative 15. And then 2 minus negative 3 turns into 2 plus 3, which is 5. And then the negative 15 over 5 can actually reduce. There's a common factor of 5 out of both of those. So we end up with negative 3 over 1 or negative 3, depending on how you want to write that. All right, so that wraps up the lesson for today. Here we talked about graphing linear functions in different forms. We talked about how to find slope given 2 points, and we talked about how to convert from point-slope form to slope-intercept form. If you have any questions for me, please make sure you're asking during our meetings or email me. But I want to make sure that you're understanding these things and not just taking notes to get credit. You got to understand what's going on. So go ahead and do the assignment associated with this, and I will talk to you later.